Hello everyone and welcome to Extra Math. Our chapter today is the quadratic equations. Let's begin with the definition. A quadratic equation in one unknown x is an equation of the form ax squared plus bx plus c equals to 0, where a is different than 0. Remark that if a is equals to 0, then the equation becomes bx plus c equals to 0, which is linear and no longer a quadratic equation. So a is different than 0 is a necessary condition. Here a, b, and c are called the coefficients of the quadratic equation. Let us now demonstrate the roots of the quadratic equation e, ax squared plus bx plus c equals to 0. First, we have to factor a from the x terms to get a into x squared plus bx over a plus c equals to 0. Now we have to create a perfect square form. So we will add b squared over 4a squared and here subtract b squared over 4a squared. Here is the perfect square form and it's equal to x plus b over 2a all squared. Here we have minus c and here we have b squared over 4a squared. Then after simplification we get a into x plus b over 2a all squared equals to b squared minus 4ac all over 4a. Here a is different than 0, so we can divide by a the whole equation to get x plus b over 2a all squared equals to b squared minus 4ac all over 4a squared. Here we have a quantity square, so b squared minus 4ac has to be positive or equals to 0 in order to have real roots. We will discuss the sign of b squared minus 4ac in a few moments later. Now let us continue the root demonstration. Here we can cancel out the square and put the plus or minus radical. So we will have x plus b over 2a equals to plus or minus radical b squared minus 4ac all over 4a squared, which is equal to plus or minus radical b squared minus 4ac all over 2a. We will bring b over 2a in the second side to get x equal minus b over 2a plus or minus radical b squared minus 4ac over 2a. So we will have two real roots. x1 equals to minus b plus radical b squared over 4ac over 2a and x2 equals to minus b minus radical b squared minus 4ac over 2a. x1 and x2 will be two real roots if b squared minus 4ac is positive. So these are the formulas of the two roots of the quadratic equation. Now the conclusion. As we mentioned before, we have to study the sign of b squared minus 4ac. Let denote by delta b squared minus 4ac, and it's called the discriminant of the quadratic equation. We have to study the three cases, delta positive, delta equals to 0, and delta negative. Here, if delta positive, then under the square root, we will have a positive quantity. So x1 and x2 exist. Then x prime and x double prime, or x1 and x2, will be minus b minus radical delta over 2a and minus b plus radical delta over 2a. Here's the two roots of the quadratic equation if delta positive. Note that x prime and x double prime are two distinct roots. In the case 2, we have delta equals to 0. Then the number of roots is 1, because if radical delta here equals to 0, then the first root is minus b over 2a. And here delta equals to 0, then the second root is minus b over 2a. We conclude that x prime equals to x prime equals to minus b over 2a. So we will have here one double root, which is minus b over 2a. In the case 3, delta negative, so we will have here under the radical sign a negative number. So x1 and x2 are not exist in R, and they are two complex numbers. So if delta negative, we have no real roots. Let's take an example. We have to solve the quadratic equation x squared minus 3x minus 10 equals to 0. Here a, the coefficient of x squared is 1. B, the coefficient of x is minus 3. And c, the constant is minus 10. Here delta equals to b squared minus 4ac equals minus 3 squared minus 4 times a is 1 times c is minus 10, which is 9 plus 40 equals to 49. The roots are minus b plus or minus radical delta over a over 2a, which are 3 plus or minus radical 49 over 2. The first root is 3 plus radical 49, 7 over 2, which is 5. And the second root is 3 minus 7 over 2 equals to minus 2. So 5 and minus 2 are the two roots of the quadratic equation x squared minus 3x minus 10 equals to 0. Here we have two formulas we can memorize. If a plus b plus c equals to 0, then the first root is 1 and the second root is c over a. If a minus b plus c equals to 0, then the first root is minus 1 and the second root is minus c over a. Now let us study the sum and the product of the roots of a quadratic equation. Consider the quadratic equation ax squared plus bx plus c equals to 0. Denote by x prime and x double prime the roots of this equation. Then their sum is s equals to minus b over a, and their product is p equals to c over a. Remark, if alpha and beta are two real numbers such that their sum is s and their product is b, then alpha and beta will be the roots of the quadratic equation x squared minus sx plus p equals to 0. Let us take an example. Determine two numbers whose sum is 3 and the product is minus 4. Here we have the sum is 3, so s equals to 3, and the product is minus 4, so p equals to minus 4. Then we can form the quadratic equation x squared minus sx plus p equals to 0, and which is x squared minus 3x minus 4 equals to 0. Here the coefficient of x squared is a equals to 1, the coefficient of x is b equals to minus 3, and the constant is c equals to minus 4. Then delta equals to b squared, which is 9, minus 4ac, which is 16, equals to 25. The roots are minus b minus radical delta over 2a, which is 3 minus 5 over 2 equals to minus 1, and minus b plus radical delta over 2a, which is 3 plus 5 over 2 equals to 4. These are the two numbers, minus 1 and 4, whose sum is 3 and the product is minus 4. Now let us study the sign of any quadratic function. Consider the trinomial or the quadratic form. F of x equals to ax squared plus bx plus c. F can be written under the form a into x plus b over 2a all square minus delta over 4a, as we proved before. This is called the canonical form of f. We have to study three different cases: delta negative, delta equals to 0, and delta positive. Case 1, if delta is negative, then f will have no real roots. Then f and a will be of same sign. Then if a is negative, then f will be negative for every real number x. And if a is positive, then f will be positive for every real number x. Case 2, if delta equals to 0, here delta equals to 0, then f can be written as a into x plus b over 2a all square. Then f and a will have the same sign, except at x equal minus b over 2a, because f will be equals to 0. Case 3, if delta is positive, then we will have two distinct roots, x prime and x double prime, and f can be written as a into x minus x prime and x minus x double prime. Here, according to the sign of a, we have the table of sign of f of x. Here, if a is positive, then before x prime, f will be positive. After x double prime, f will be positive. And between x prime and x double prime, f will be negative. Here, if a is negative, then before x prime, f will be negative. After x double prime, f will be negative. And between x prime and x double prime, f will be positive. Here we have plus plus as a, and here we have opposite to a, minus. Here we have minus and minus as a, and here we have plus opposite of a. So we can memorize the formula same, opposite, same. Same as a, opposite as a, and here same as a. Same and opposite signs of a. Let us take an example. We have to study the sign of x squared minus 5x plus 6. Here, the coefficient of x squared is a equals to 1, which is positive. Now let us find the roots. Delta equals to b squared minus 4ac, which is 25 minus 4 times 1 times 6, equals to 25 minus 24, which is 1. Here we have 25 and not 9. Then the roots are minus b minus radical delta over 2a, 5 minus 1 over 2, which is 2, and the second root is 5 plus 1 over 2, which is minus b plus radical delta over 2a equals to 3. Here we have the first root 2, the second root 3, f is 0 at 2 and 3, and here we have same as a, opposite of a, and same as a. This is the table of sign of f of x. Now we have to study the sign of the roots, not the sign of the quadratic equation, but the sign of the roots. Consider the quadratic equation ax squared plus bx plus c equals to 0, where a is different than 0. Designate by x prime and x double prime the two roots if they exist. Remark, let we have the convention that x prime is less than x double prime. This is the sum and this is the product. In the first case, if the product is negative, then one of the roots is negative and the other is positive. Then x prime is negative and x double prime is positive. If delta positive or equals to 0 and the sum and the product positive or equals to 0, then the two roots will be positive. Here, if delta positive or equals to 0, product positive or equals to 0, but the sum is negative or equals to 0, then the two roots will be negative. Thank you for watching.